Did I mention that I like survey data, especially in the context of electoral forecasting? Probably not, because I'm a pretty shy and reserved man. Why? Why are you laughing? Yeah, that's true, I'm not that shy. But I did mention my interest for electoral forecasting already on the show. And before doing a full episode where I'll talk about French election, yes, that will come at one point, let's talk about one of France's neighbors, Germany. Our German friends had federal elections a few weeks ago, consequential elections, since they had the hard task of replacing Angela Merkel after 16 years in power. To talk about this election, I invited Markus Gross on the show because he worked on a Bayesian forecasting model to try and predict the results of this election, who will get elected as Chancellor, by how much, and with which coalition. I was delighted to ask him about how the model works, how it accounts for the different sources of uncertainty, be it polling errors, unexpected turnout, or media events, and of course, how long it takes to sample. I think you'll be surprised by the answer. We also talked about the other challenge of this kind of work, communication. How do you communicate uncertainty effectively? How do you differentiate motivated reasoning from useful feedback? What were the most common misconceptions about the model? That kind of stuff, right? Markus studied statistics in Munich and Berlin and did a PhD on survey statistics and measurement error models in economics and archaeology. He worked as a data scientist at INWT, a consulting firm with projects in different business fields as well as the public sector, and now he's working at Flix Mobility. This is Learning Bayesian Statistics, episode 52, recorded November 3, 2021. Welcome to Learning Bayesian Statistics, a fortnightly podcast on Bayesian inference, the methods, the projects, and the people who make it possible. I'm your host, Alex Andorra. You can follow me on Twitter at Alex_Andorra, like the country, and reach a true Bayesian state of mind by visiting learnbayesstats.com. That's learnbayesstats.com. Do you want to support the podcast and unlock exclusive Bayesian swag at the same time? Then you can visit my Patreon page at patreon.com/learnbayesstats. Starting at €3, you can get various benefits like the private MBS Slack channel, early access to special episodes, selecting questions for episodes, or even coming on the show. You'll get more details at patreon.com/learnbayesstats. Thanks a lot, folks. I'm very grateful for any support you can bring me.
Let me show you how to be a good Bayesian. Change your predictions after taking information in. And if you're thinking I'll be less than amazing, let's adjust those expectations.
What's a Bayesian? Is someone who cares about evidence and doesn't jump to assumptions based on intuitions and prejudice. A Bayesian makes predictions on the best available info and adjusts the probability, cause every belief is provisional. And when I kick a flow, mostly I'm watching eyes widen, maybe cause my likeness lowers expectations of tight rhyming. How would I know unless I'm rhyming in front of a bunch of blind men dropping placebo-controlled science like I'm Richard Feynman?
Hey folks, before listening to Markus, I want to warmly thank all the new members of the LBA's Patreon, especially those in the full poster tier or higher. This time, I'm talking about the tremendous Ryan Westland, Andreas Netti, Riley King, and Aaron Jones. Your support helps me pay for editing, manage the community, and, well, just improve the show in general, which I'm sure you are all in favor of. So I am very grateful for your support. Okay, now let's talk electoral forecasting with Markus Gross. Markus Gross, welcome to Learning Bayesian Statistics.
Thank you for inviting me.
Yeah, you bet. Always a pleasure to talk about electoral forecasting. And I have the feeling I could have invited you before because now the German election is over, but it's actually interesting to take stock of models once the election is over. And now, actually, we're going to have the ability to talk about, okay, what happened before the results, what happened after. So I'm actually glad we're doing that now.
Okay.
But, as always, let's start with your background. Who are you, Markus? How did you end up in the stats and data world?
Yeah, As I was in school, I just had some affinity to mathematics and especially stochastics. And then I found out that there's a field called statistics at the universities, and this is pretty unknown in Germany. So in the Anglo-Saxon countries, USA and UK, for example, statistics is quite common actually. But in Germany, if you talk to somebody that you could study statistics, that was pretty much unknown. And when I started back then, data science was not something. It was pretty much maybe in the early stages or something. And I looked into it and I found it pretty interesting, all the problems you could solve, and especially that you could apply statistics in any field at university, but also in business. And this was really driving me into it. Yeah.
Okay, that's funny that you'll say that, because that's a bit of the same situation in France, I'd say. Statistics has picked up since, but I guess I did my graduate studies in the early 2010s, and so data science was starting to pick up, but not the huge thing it is right now. And I remember that when I first started studying statistics and even Python, Python, I don't have to explain what this is to non-nerdy people, but before I had to, I was saying, okay, so Python is used in these cases on these websites, blah, blah, blah. Whereas right now, most people know what Python is. It's quite funny to have seen that popularity picking up. Was it the same in Germany?
Yes, we all started with R, right? And then Python became more and more popular. And I would say since 2014 or 2015, it became much more prevalent in the data science scene and also a bit with statistics. I like both. I use both for different projects, so I'm really familiar with both. I'm not really saying that one of the both is better in general than the other. For data science or statistics, both have their advantages and disadvantages, so it depends.
Yeah, clearly. I can guess that. And so you basically were drawn to statistics very quickly, right? Mm-hmm. Because you don't seem to have meandered a lot in your path. Am I right?
That's right. I had some side courses at university and I just had a bit of a feeling of other fields then. But it was pretty much straightforward. It was not much about data science back then, as I said, but it's more my interest was in statistics. And then pretty much everyone who started with me in statistics, we got into data science and are now part of it. But there are also the foundations, the theoretical and mathematical foundations. I think they are very important. And I think statistics is a field, or data science is a field where you can do a lot of things wrong. So I think it's very useful to have a solid background, solid foundation in the mathematics and statistics.
Mm-hmm. And do you have any particular area of statistics and mathematics you are fond of and interested in? Because these are huge fields. So of course you cannot be an expert and familiar with all the dimensions.
Yeah, sure. In the last years, I got more into Bayesian statistics. And in Bayesian statistics, I had a lot of projects in my PhD, for example, in a measurement error model, when you cannot measure what you actually want to measure, but you measure something which has some error in it and you don't have the true values, and you try to fit a model around this and try to incorporate the measurement error that it doesn't make your predictions or make your inferences worthless. This is a big field which I'm into.
Yeah, and I'm guessing that's what attracted you to Bayesian stats, right? This ability to estimate measurement error and to incorporate that into your models.
It's basically data augmentation, and this is also the way I came into Bayesian statistics, because I had a project where we had a lot of measurement error in different variables or features. And I researched a bit, and the Bayesian approach of data augmentation, that you see or regard the true values of your features as additional parameters. So you have the true value, which is a parameter to estimate actually. And this approach was really made sense to me, and I followed this approach and came into Bayesian statistics in that way, more or less.
Yeah. I see, I love that. And I basically have the same story with Bayesian stats, actually. Like, really starting with electoral forecasting and then discovering that what I'm interested in is not only estimating the mean, but estimating the full distribution of scenarios and the uncertainty and all that, and digging and then coming to Bayesian stats and then PyMC. And then I was like, oh, this is awesome. I gotta do that right now. And the rest is history, as they say. So yeah, basically the same story. And I remember I was amazed at this ability to add measurement error in the model. And just this beauty of one of the most important principles in Bayesian stats is if you don't know something, put a distribution around it.
Yeah.
And so measurement error is like that. It's, you imagine that it's super complicated to add that in model, and then you discover, oh no, just add a prior around your data and you're done. It's like, really? Where's the trick? Yeah, I completely understand.
Yeah.
It's really...
Yeah, I mean, like things like measurement are really complicated, like to have, like to incorporate like a maximum likelihood model or something. And in the Bayesian statistics, you can just write it down sometimes, like depending on your framework, but sometimes you just write it down and it works. So this is like really nice. So yeah.
Definitely. And so how would you define what you're doing nowadays?
Yeah, nowadays I'm mostly into, data science. I'm not so much into data engineering, but rather the like actual modeling. So I do understand all these frameworks, but I'm more thinking about how to, from a business perspective, how can the data be used, what to do with the data, what kind of model, where do you have to pay attention, where could be potential problems be, and depending, what you want to achieve, like maximum predictive power or some insights into the data, I develop models. We implement them into production with our data engineers, and that's basically it. Otherwise, I also work as a side project. I work on a Shiny apps, like web applications that incorporate like modeling online, where you can just upload data and then you can fit also Bayesian models in it. These are some geospatial models which you can just fit online and display them, see the graphs, export, and so on. So this is basically what I'm doing right now.
I see. Yeah. And so from what you say, your preferred Bayesian workflow is in R. And so I'm guessing Stan?
Yeah, Stan. It doesn't make really a difference if you use R or Python. You just have to format your data in the right format such that Stan can use it. But I mainly work in R with Stan. Yeah. But somehow there's a high correlation. If you're using R, probably you're using Stan. There's a high correlation. I haven't tried PyMC yet. All the Stan people say, okay, Stan is a bit better actually, but I'm really not... I should try it. If you can recommend it, I would be eager to try it and maybe test the same models on different frameworks to just better get a feeling what is better in which situations and so on.
Yeah, definitely. Sure. And I actually have an electoral forecasting model. I'm working on it right now, but hopefully it will be done. Famous last words. Electoral forecasting model for French elections using PyMC. So maybe that should be of interest to you.
Sure. Let me know when you can present something or GitHub repository or something.
Yeah, definitely. I'll let you know. For now, I have a huge pull request with way too many commits on it. So it's really not something you want to look at. And I'm wondering in general how Bayesian is your work, actually, because you work in a company. So how much, what's the proportion of topics you have that are where you get to fire the Bayesian framework and other topics where you don't?
I would say it's 90% non-Bayesian and 10% Bayesian.
So maybe that's the proportion of just statisticians in the world. 10% are Bayesians.
Yeah, sometimes in business you just throw like a gradient boosting model on some data or something, and then that's it. There's no need sometimes to just use Bayesian models, but sometimes applications. For example, I had some months ago an A/B testing project where we had a custom implementation of A/B testing for a customer. And so I proposed to use Bayesian modeling because then you can more easily derive uncertainties, probabilities, which one is better, and so on. But mostly it's non-Bayesian actually.
Yeah, A/B tests perfect setting for the Bayesian for Bayesian stats, and also because you can do A, B, C, D, E, F, G tests if you want, and that's not a huge headache as it is in the classic framework.
Right.
So definitely, and yeah, I can testify, built a company around that a lot of times. You can use Bayesian stats in industry. And let's talk actually about your model now. So you built a model with, I guess, other contributors that you can cite here for the 2021 German federal elections. So before diving into the model, how did this project come into being, and why did you start working on electoral forecasting?
Yeah, I was in 2016. I was in the USA, and I followed the election back then. And yeah, I saw all the election models, like from 538 or the New York Times, and I wondered why such things that don't exist in Germany. And I had the idea to just, also create a model for Germany, because I think this is a really interesting topic where you can use Bayesian statistics, where you can just take publicly available data and then fit pretty complex model on it. And I just tried it on the German poll data. And in 2017, we had a first project on it. It was not non-Bayesian, it was frequentistic. There were several models, which were one model for the uncertainty and one model for the mean prediction and so on. And afterwards, I thought, okay, it somehow worked, but it's much nicer to have it all in one, to have a model that estimates everything at the same time, that gets the uncertainty. So I started to develop a Bayesian model after the 2017 election. And then I followed this project. I tried different approaches, developed the model further and further. And in 2019, I was at the StanCon. This is just a conference for Stan where I presented a preliminary model. And last year in 2020, we decided to make a project in my previous company, ENVT Statistics, and such that we create a full web page where you can follow the results every day, predictions every day. And we started at the beginning of this year, where we published our website. The model was finished in 1 year ago, in end of 2020. And that's basically the story behind it. So I wanted to have a forecasting model on elections for Germany.
Yeah, but why? So that's funny, because I have a very similar trajectory, and started actually going into Bayesian stats because I was interested in electoral forecasting. And somehow, almost 5 years later, this project is still with me, although I've grown into other topics and fields. But weirdly, this first project and these electoral forecasting models stick with me like a virus. And I think I have understanding of some of the reasons why, but I want to hear your reasons why, because you've worked on that for 5 years now almost, right? Like me. And so I'm wondering why you keep getting interested in this model, because from the outside, we could think, okay, you did one model for one election. Now maybe you're interested in something else, but no, you kept with it, and it's the same country, it's the same parties and so on. So what's interesting what's in it for you?
I think the interesting part of it is that this is a topic where everybody can identify with. It's not something you can have a very cool model on a field or data which nobody's really interested in. But this is data everybody knows, everybody follows the polls, everybody follows the elections. So it's relevant for everybody in the country, yes? And this is nice because you can combine statistics and Bayesian modeling with a really relevant topic. This is the major take here, I think. And also for my previous company, it was a really nice showcase. So starting with, developing a model, then implementing this model, developing a web page where you have all data and predictions available and make it transparent, creating a GitHub repository and so on. It's the relevancy, I think, for the public, and in combination with the, sophisticated statistical modeling. I think this is the main point here.
Yeah, and the website, by the way, the web page is really good. I love it. The visualization are really sleek, and I find that super nice, really well done. And yeah, I agree with that. And in fact, I think something I like is a paradoxical point that you want to tell people that it's better to trust the model than just the raw polls, but you shouldn't trust the model too much. And so I love making that point because it just makes everyone confused. Because you've got these kind of extreme reactions to models. It was the same thing for models during COVID. So either people don't believe it at all, and so it's all garbage and we don't know anything and we're all Jon Snow, or like, no, models are awesome and we should completely believe them and we should buy completely into them. And so you've got this kind of really huge standard deviation on the reactions and not really something in the middle. And so that's something interesting to me to understand why. First, I think one of the reasons is that our brain just doesn't like uncertainty too much, and also then try to explain to people that it's not because a model is not 100% trustworthy that it's 0% trustworthy. And that's weird because it's not a very deep point, but it's weirdly a point that you have to make over and over again.
Yeah, I think these two poles, some people just ignore the uncertainty and take the predictions as they see it. And other people say, okay, there's large uncertainty, so it's useless. In the end, it's between these both things. And it's hard to communicate this to people, like that it has some uncertainty, and the uncertainty is quite large actually in many cases, but it still is somehow useful. Yeah, this is the hardest thing to communicate actually. Yeah, the major.
Yeah, and that's why to me it's also interesting. It's because the statistical challenge is it's fascinating, and that's why this is noisy data with complex socio-economic interactions that make the latent variables very interesting and hard to estimate. So the statistical challenge is very interesting, first, for you as a modeler. But it doesn't stop there. And the visualization and the communication challenge is almost as big as the modeling challenge, actually. Because you can have a really good model, but if you cannot help people see the difference with a simple pole aggregation, then probably there's something went wrong somewhere. And so that challenge is very interesting too. And to me, at least for me, harder than the statistical challenge itself.
You have to be very careful what you communicate, how you describe your results, and how you don't want to be like superficial, but but not too complex in your how you communicate or your model basically and your predictions.
Yeah, exactly. And then the use of, statistical lingo and so on. It's quite hard. Like, I love HDI, but I cannot say the 94% HDI stat. And so that's frustrating. But that's a good challenge. Actually, I'm wondering how much time did the model take to develop from start to finish?
I think the Bayesian model was about 2 years, but I didn't, of course, work all the time on it. But like when I had some time, some free time, or then I worked on it and improved it regularly. All in all, I would say maybe 2 months full time. Yeah, it was quite a lot of work because the model is quite complex in the sense that it's really going deep into several hierarchical levels. When I had really large problems how that it would fit actually with Stan, and to make it fit, to reparameterize my model and so on. So this was one major point here. And of course, trying out different approaches, different model formulations, which worked better on forecasting previous elections. And yeah.
Actually, how long does it?
It depends on how much iterations you run, but we chose to update. Sorry, there's just some noise. I don't know if you hear this.
No, I think it's okay.
Okay, then
How much time does it take to sample?
But in our project, we wanted to have daily updates, such that we decided to don't run that many samples. In the end, it takes about 15 hours to sample. But of course, if I would had the choice, it would be like a bit more, like maybe 24 to 36 hours to have more iterations and get a better approximation or a better result actually. So this was like something we had to make a compromise here, that we could give daily updates on the webpage.
Yeah, for sure. Yeah, because if the model takes 26 hours to run, then daily updates are a bit... maybe on another planet, you can do that. But on Earth, it's a bit hard. And so was the sampling time mostly driven by by the size of the data or because of the random walk? Because you use a multivariate Gaussian random walk. So that's a lot of parameters, especially if you do that for all the previous elections. So what was driving the sampling time?
Not actually the random walk itself, because it's not a classical random walk. So I'm not, I should go as deep into it right now, but it's not it's not a classical random walk, but it's like an adjusted random walk where because I found out that if I fit a random walk, the data doesn't really follow a random walk. What you have in the end is that the long-term variance of your party vote shares is smaller than you would walk, and it's the party vote shares are much more stable long-term. There was like another step apart from the random walk where you had these autoregressive processes where you had a kind of a diminishing effect on how each shock. So in a random walk, you can say, okay, you have some shocks in the vote share, and these shocks, have a peak after 4 or 5 weeks, and then they diminish somewhat, so that you have a much more stable vote share long term. And what takes the most time is the hierarchical structure. So you have the poll, and then you have the true vote share. And how you get from the poll to the true vote share or the true vote share estimate is like several steps are involved. So you just...
What are you saying? The true vote share?
The true vote share. So the poll isn't the true vote share. So the true vote share at some point t, right? Suppose you are in week 2, 2021. And the true vote share I define as what would be the vote share of a party if the election would be held in this week. Yeah.
Oh, okay. So the latent. Okay.
And to come to this latent variable from the poll, you have to make several steps. You have the poll results, and then each pollster has a kind of a bias. So, for example, pollster A always overestimates party B, for example.
So historically, you mean? Like historical bias.
Yes, historical bias.
It's not what's called the house effects, which are not the bias, but the tendency of some pollster to overestimate or underestimate some parties during the election cycle because they depart from the average.
Yes, actually, my model has two kinds of housing effects. So one is the long-term housing effect, and the second one is short-term house effect, which is like within an election cycle. And
so what you call the long-term house effect would be the bias?
Yes. Yeah. And house effect is bias.
Yeah, in the literature it's not. Yeah, but I agree. It's like house effect is almost a bias, but by definition it shouldn't be the bias because you don't know the election results yet.
Yeah, sure. And you have the long and short-term house effects. Like the long-term house effect is the bias, and the short-term house effect is only within the election cycle.
Yeah.
And then, if you look at the previous elections, there were always some cases where all pollsters were off, like they all overestimated some party by a certain amount of vote share, and this is actually quite surprising. Or not surprising, but actually you see when this happens that the pollsters are not independent. There's a common pollster error, I would say. They tend to overestimate or underestimate a party together at the same time, and this common pollster bias is something that you cannot know in advance, So it's distributed around 0, but this is something which is in the way or in the process of getting rid of all the effects to go from the pollster results to the true latent vote share. And then you got rid of the bias in the model, and then you have all these like diminishing short and midterm effects where you have these shocks and which diminish over time, and then if you subtract these effects, then you get to the true vote share. So you have several levels of hierarchy, and this is a state space model, and these kind of state space models are notoriously hard to fit, except you have you apply a Kalman filter or something which is like really basic, but in this case it wasn't possible. So it's like very custom, and in this case it's really hard to fit for any kind of modeling framework.
Okay, that's super interesting. And so you're talking about the different hierarchies. What are those? So is it that the state level and then the whole national level, or how does it work?
No, not in that sense. It's more what I just explained, that you have the true latent vote share and you add specific items to it such that you arrive at the pollster results which you can observe. So between the things you want to measure, the latent true vote share and the pollster results, there are different steps where you add house effects, biases, and all these kind of time series effects, which I mentioned earlier. So this is a lot of between steps that the model has to...
Yeah, I see. But I love that because you can really relate that to the domain knowledge. Like you can really, like your model is telling a narrative, a story about how you come to observe the polls. And those polls that you observe actually come from a latent structure that you never get to observe, but that's there in the world. You just don't see it because you're not omniscient, but it's there. And you've got this story in your model that tells, okay, I think that's how it works.
Yeah, exactly.
And that's how we come to observe the polls that we do observe.
Yeah. You can also translate this into different like uncertainty effects. So you have the uncertainty about your future events. You don't know about future events. These are shocks. You don't know the direction. You don't know the size, but you can form a distribution around it. The U size is around this and this. And you can impose a multivariate normal or multivariate T distribution on all your parties. And then the second level of uncertainty is the uncertainty in polling. So as I said, you have the polling uncertainty of a specific pollster, then the polling uncertainty of a specific pollster for a specific party, and the common bias of all pollsters for a specific party. So you have different, say, levels of uncertainty here. And you have to incorporate all of them into your model such that it gives useful results and it doesn't underestimate the uncertainty.
Yeah, it's crazy how relatively simple observations that are polls are asking for complex models to account for all the different effects that you have in the campaign. And okay, so you've got one time series per party in the end, which is like trying to infer the true latent party support for each party. And each of these time series is related to one another through the covariance matrix of the multivariate random walk.
Yes, right.
And then you've got your likelihood, which is probably a multinomial in the German setting.
I tried that, but I didn't use this kind of approach. But what I use the log transformation on the vote share.
Oh, okay. So you use a multivariate Gaussian random walk likelihood.
A multivariate
Gaussian likelihood.
A multivariate Gaussian likelihood, but the shocks in the random walks or the steps in the random walks are multivariate T distributed.
Yeah.
It doesn't, if you look at the model formulation in the stand file, for example, it's not that obvious because of reparameterization but it's a T distribution inside of the model.
Yeah, okay. So like your likelihood is a multivariate Gaussian, then you've got the latent party support, which is a multivariate Gaussian random walk, and to that, you add shocks that are multivariate student T distributed.
Yes, the reason is if you follow the vote share of a party, you can do this like by the pollster results, for example, that you can just plot in time. And then you see most of the time doesn't happen anything. And then suddenly there's some large shifts in the vote share. And if you do model this with a Gaussian distribution, this doesn't really fit it very good because it has really long tails. So sometimes there are really large shifts, which cannot really be explained with a Gaussian distribution. To better model like these large unexpected shifts, I used a T distribution here.
Yeah, that makes sense. And I'm curious about so before we get into that, thanks for that conceptual overview of the model. Any other thing you wanna add to that, or you think listeners will get a good idea of the conceptual building blocks of the model?
This is a good overview of the building blocks of the model, but it's important to know that there are actually two parts of the model. So this is the first more complex part, but there's a second part where we not only want to predict the vote share, but also to predict the probabilities that a certain party gets into the government, that a certain person gets a Chancellor in Germany, and so on. So for that, we had to model coalitions. And coalitions are something, for example, they don't exist in the US, but in Germany, where you have a multi-party system, like more than two major parties get together to get a majority in the parliament. And coalitions can be 2 parties or 3 parties or even 4 parties. And for a given voting result, for a given election result, it's not really clear, how's the government constituted in the end. So it could be either a party A and C or party B and C, which both have a majority in parliament. And to account for this and to give more, this is also, of course, of interest for the reader or for the people. You want to know who is the government after the election. And to model this, we asked experts, and they should rank potential coalitions, and they should rank them such that the ranking is independent of the voting result. So they should imagine of a situation where people of a party, of all parties, you put into a room, and they should have the goal to create coalitions, like find together. And then the experts had to say, okay, who do you expect to find together first, and then second, and so on. Yeah, and we also employed a Bayesian model here to derive predictions on that on top of the vote share model. So how this works is basically that we derived, say, 1,000 simulations of the vote share of the election result. And on these 1,000 simulations, we put on top the government or coalition model that gave for every of these 1,000 simulations also an outcome, which were then aggregated to state how likely is it that, say, Olaf Scholz gets Chancellor, what is the probability that we have a government with the Green Party, and so on.
I see. Yeah, that's fun. And I'm wondering, so on the vote share model, you're doing out-of-sample predictions, right? And so first, how far back in the campaign are you going? And second, did you notice a point where the out-of-sample predictions were basically a bit useless, and so maybe, 3 months before the elections doesn't really make sense to make out-of-sample predictions because the uncertainty is so huge on election day? So what was your experience on that front?
So we did only go back like 1 year in our out-of-sample predictions. Also, we published the model at the beginning of the year, so 9 months in advance about. And so what we found out is that our model, or the model, what we found out is that the polls, the aggregated polls, are not really worse than a sophisticated model when it comes close to election. So close to the election, you have only like single-digit percentage advantage over the poll aggregate, but the farther back you go, the higher is your advantage, because the polls are fluctuating very strongly, while the model is more conservative, and this conservativeness helps that the long or midterm predictions are superior compared to a simple poll aggregate. But short term, there's something you can do. It's a bit better, but not much really. And we didn't go back more than 12 months because I think it's not really the interest of the public.
Yeah, but that means you already have. So you have enough data to go back 1 year before election day for each election.
Yeah.
Are all the parties always present in all elections? Because, for instance, in France, you can have, so for instance, the last presidential election in 2017, the Green Party was not there. So you've got basically 6 big parties in France, including the Green Party, but it was so weak in 2017 that it wasn't even competing in the presidential election, whereas it was there in 2002, 2007, 2012, and will be there probably in 2022. So I'm wondering, how is it structured in Germany? Do you always have the same number of parties there? Do the parties change? How do you handle that in the long-term model?
Yeah, the parties change, of course. There was not that much change in Germany, actually. Only the emergence of the right-wing party, in 2013. This was a new party which came into the other 5 big parties. And what the model does is actually that it starts, we have latent values for each party for each week, from 1998 until 2021. And before, we just have missing values for the AfD before it was created or something. And it was basically 0 before. You can say, okay, it's 0%. The approach is not clear, really. It's also a problem with the pollsters that the pollsters only publish results for larger parts. At one point, if, for example, in France, if your Green Party disappears in the polls, you cannot really measure it anymore. So it's hidden in die Sonstige, so other parties in the pollsters. It's really tricky. But we decided to have a latent value for the complete time interval for each party. So you estimate something.
You have zeros.
Yeah, basically, yes.
Nice. Okay. I see. Yeah, it's really that weird idiosyncrasies that can make you bang your hand against the walls when you're modeling. And in the end, often it's a simple solution, but it takes some time to come up with it. Right. Yeah. And so how do you assess your model performance, both before and after the election? So before the election, when did you decide, okay, that's a good enough model, let's deploy it to production? And then after the election, how did you judge its performance?
Yeah, of course, we made an out-of-sample prediction with our models, like on the 2 previous elections. And we did not only do this once, but in time steps of 1 month. So we started 18 months before the election and then increased our training data set by 1 month and had an estimate based on the root mean square error as well as absolute error on the percentages of vote shares. And so we did this for each month prior to election, from 18 months to just before the election. And we did this for the elections 2013 and 2017. The reason why we didn't go further back, like for example, elections 2005 or 2009, is that the model needed some data to be fit. For example, for the common pollster bias, for example, where we needed more samples actually, and also the house bias, which was a bit, hard to estimate if you have little data. And then we had an aggregate measure, 18 measures for 2013 and 18 measures for 2017. And so we could compare different models, compare how like a competitor would perform. Our competitors were, for example, like you took always the latest poll, or you took the average of the 5 most recent polls, so that you could compare your model performance compared to some simple poll aggregates, which are easy to create.
Mm-hmm. And then, so that's for before the election. And now that the election has passed, how do you assess your model performance?
Yeah, we did actually exactly the same. We published our results on the web page, so everybody can download the CSV file and see how our predictions were in the preceding months. And then we did actually the same, that we say, okay, for every day we had our prediction, we compare the difference to the model to the election result. So you could or the mean absolute error for each day, and then you can compare to the aggregate and to assess whether the model was any good or not. But the model performance is not the only one. So like the predictive performance is not the major thing. I think for the model to be important or to be of relevance, but it's also the communication of uncertainty, so that you can say derive also measures like how likely is it that a certain party gets into the parliament, how likely is it that party A is stronger than party B, and so on. And so this gives much more information than a simple poll aggregate, for example. Even if our model is not better than a poll aggregate, you have additional information which is useful for the reader.
You have uncertainty.
Yes.
You have the uncertainty estimation, you have the ability to generate scenarios. Mm-hmm. So it's like your coalition scenarios. Yeah. You cannot do that with the poll aggregation. And also you have the more explanatory power with the model, right, because you've got structure. You cannot explain how the campaign is going if you don't have a structure for how the campaign is usually going on. So if you don't have a model, you cannot explain that. So clearly, without the poll aggregation, you cannot do that.
Exactly.
And I'm wondering, because each time I work on a model, I have to deploy it into production at some point. But there are often known limitations that I like to improve for the next iteration. And I'm wondering, what would you improve today if you had time in your model?
Yeah, one thing that became obvious during this election cycle, or the 2021 election cycle, is that there were the variance in the sense that there were much larger swings in the vote shares than usual. So I calculated this, and if you make some statistics on that, you see that the swings have almost doubled in comparison to the previous election during the campaign.
Okay, so the campaign was more volatile.
Yes. And the model doesn't really account for structural breaks or something like that. If the model of the underlying structure, like the underlying process, the data generating process, is behaving differently, it's always hard. Like in time series, if there's a structural break, it's hard to account for this. And we didn't really had a plan for this. The variant changes, that the shifts in the random walks, that they are larger than before. So this is something that we didn't account for. And yeah, I would like to make a change here so that like the more recent volatility is more taken into account. I also, try to incorporate a rating, so time rating, but I decide against it because it's not really a Bayesian thing, and many Bayesians are against weighting the likelihood with, say, you can make like an exponential decay weighting of your observations, so that observations that are like 20 years or 15 years old do not count that much into your likelihood. But I decided against it, although it does somewhat improves the estimates. But yes, this is a kind of a trade-off. Either you do something like this or you incorporate changing parameters over time, which is always making the model more complex. So that's
the trade-off here. But that's true. It's better to have that in the model. Like in an ideal world where you don't care about model sampling time.
Yeah.
That's always better to have that in the model. So I understand why a lot of patients are against that. But yeah, sometimes you've got to make these trade-off anyways.
That's true. Another thing I would incorporate is the long-term trend of the parties. What we have incorporated that like you have a shift, for example, a candidate is announced or there's a scandal in the party or something, and the vote share increases or decreases by quite a bit. And what you said in short or medium term, these kind of like shift tapers off, and so that in the end your vote share of the vote share of a party is more like
comes back.
It comes back and is more stable than implied by a simple random walk. And I would go one step further and introduce a long-term trend, which I think could improve the results further, in the sense that like what we integrated or implemented is like a short and medium trend, which is about like maybe 3 months in time interval, but a long-term trend could really better account for long-term trends and maybe improve the model. I have to test it, but still it could be very useful.
I see. Yeah. I understand that. I would have the same idea for France. I think it works similarly. And did you get some feedback on this model and on its impact?
Yeah, we did quite get some feedback. It was really mixed. So some people really liked the model and they said, okay, we follow the model. We had also some presentations, in the media as well as for institutions. But other people didn't really like it. They said, okay, it's total garbage. Why do you need election forecasts anyways? And the model does, and they didn't really look into the model. They said, okay, the model doesn't account for this and this. And I said, okay, it does account for this and this. So the critics sometimes didn't look at the model at all. And sometimes I had some discussions with some people, like random people, which were like reacting to our model. So it was really mixed.
Yeah. So I am happy to see that motivated reasoning is as strong in Germany as in France. That's all reassuring, but that's almost boring. It's almost the same critics everywhere. So I was almost sure that you were going to mention people like just asking about the usefulness of all that, which you can, but usually it's not really properly done. So I should reformulate my question and say, did you get any useful feedback about the model?
Yeah, we had a lot of feedback on our expert interviews and the expert model. So the government model, which tried to predict the outcome of the government forming, the coalitions and so on. And we came to the conclusion that it might be better to don't use expert interviews because it's really hard to get experts to do this. And the other thing is that you often get criticized because how are these experts selected? It's really time consuming for us to do, and sometimes you have a hard time to tell the experts how to fill out the expert interview or the expert poll, the coalition ranking, and that's really hard. And I thought about using a database model, which might be much less prone to criticism because you can better explain how you did it and not rely on experts, where the selection is always a bit tricky and the interviews are not easy.
So that's interviews that you conducted for the second model, the coalition model?
Yes.
Okay. And so maybe quickly before, because we're running short on time, but I have two last questions before the two last questions. Maybe what were or are the most common questions or misconceptions about the model that you had to encounter?
The one misconception was about what the model is trying to predict actually. So many people thought it was like not trying to predict the election itself, but rather the current state of the vote shares of the campaign. But that's not true. So our model tries really to predict, including future uncertainty because of unknown events, the actual election result. So this was one misconception. And the other one was trying to explain uncertainties and different measures of uncertainty. People had a hard time if you present like the vote share, and it's for party A, it's between 28 and 32%, for example. So you have a kind of 95% uncertainty interval. And then we had an estimate, for example, on a candidate that, for example, Martin Schulz gets Chancellor after the election. And, for example, that we would say it's 70%. And then the people wondered why we don't have an uncertainty interval around this 70%. If you do the simulations, you have 1,000 simulations, and then you create a probability for an event. For example, like party A gets more than 30% of the votes, and then you get a certain percentage. And the people didn't understand what is the difference between uncertainty and probability percentage, because in the probability, the uncertainty is already included in some way. Yes, if you are 100% sure or 0%, then the uncertainty is 0. But if you say, okay, the probability that for event A is 50%, then your uncertainty is really large. And that was something people always asked questions about and did not really understand often.
Okay. That's good to know. Probably something to have in mind for the next selection around. This is also why this is super interesting. You get to do a lot of experiments and see what works and what doesn't on the communication side.
Yeah.
Okay, and maybe real quick, what was the main challenge you faced on this model? Like, what would you say was the most complicated things in this whole workflow?
The main challenge for me was that I had a model in mind and to make it work in Stan. Or to work it in any framework. I wrote down the model, and I needed many tries to reparameterize the model, to reformulate the model, and so on. That really did estimate in Stan actually, so that the MCMC sampler did run through. So this was the main challenge actually. So I had a model in mind, and you can just write it down, for example, in Stan. But then always estimation is a thing if you have like this hierarchical structure that it produces, that it converges, that it produces useful results, and that you produce results in not in 2 weeks or so, but rather in some hours or 1 day or something. And this was really the main challenge where I spent most of the time with.
Yeah, I can relate to that. That's a very classic challenge. I have that almost all the time. Awesome, Marcus. Thanks a lot. Before letting you go, though, I have to ask you the last 2 questions I ask every guest at the end of the show. So, number 1 is, if you had unlimited time and resources, which problem would you try to solve?
Yeah, lately I thought a lot about A/B testing as something where you have different alternatives, for example, different prototypes of a website, and you want to find out which is the best one. And I think the current approach is really short-sighted or a bit like shallow, because people are trying to optimize not the outcome, which is like the revenue or the clicks on your website, but rather to find out which is the best alternative. And they use methods which do not really optimize or maximize the outcome which you are actually interested in, but rather these kind of proxies. And I think there's still a lot work to be done, because it's really a difference if you like, for example, you have, say, 2 prototypes of a website, and for a new website, you work like 1 year or something on it, and you make an A/B test, and it says, okay, the newer one is not really better than the older one, and then you just discard it. And another case would be that you, just change a small button or something. And but these kind of really fundamental different things, because what this implies in the future is that if you make a small change, the small change is likely to be not really persistent over a long time. But if you make a strong change, it's really something fundamental where you have much more risk, but much more potential benefits. So I think there should be more focus on how to set the cutoff points when to make a decision. And these kind of decisions which are made currently are based on, say, the simple statistical tests where you just set an arbitrary limit, 5% niveau or something, or you compute the probability to be best. And this is also not really optimal because you always choose the confidence level or uncertainty level, not really based on what should optimize your outcome in the long run, but rather on an arbitrary value. And I think there's a lot of work to be done, and I have some ideas about it. And if I could, I would invest much more time in it, because I think this is also interesting from a theoretical perspective. Yeah, really.
Yeah, okay. Yeah, you seem to like the theoretical, mathematical side of things. And second question is, if you could have dinner with any great scientific mind, dead, alive, or fictional, who would it be?
Yeah, I think it would be Richard Feynman, the famous physicist. He's really both entertaining and really smart. And I think he always he doesn't like bullshit, and he does clear structures, clear explanations. And I think this is really important if you are in statistics or data science, that you don't get too much confused with the small details. But the first thing you have to do right is the overall structure, the overall thing, especially when you do Bayesian modeling. Your fundamental model should make sense. And if you have an idea what you want to, I think, then it would be really cool to talk with him.
Yeah. Definitely. Awesome. Vielen Dank, Markus. That was great talking with you about electoral forecasting models. I think you could tell that. Plus, I'm really into the model for French elections right now. So my mind is really, a part of my mind is focused on that. So that was really, really interesting and illuminating to have you on the show. I hope listeners learned a lot like me and were as interested as me. As usual, I put resources and a link to your website in the show notes for those who want to dig deeper. Thank you again, Markus, for taking the time and being on this show.
Yeah, thank you, Alexander. It was really nice talking to you, and I hope I could give a bit more insight into my model. And if you are further interested in what we have done, you can always look at our website. There's also a lot of material on our GitHub page where you have more insights into our model. There's a presentation, there's a paper which describes every detail of our model. So, and if you want to give me feedback, it's also very welcome. Yeah, thank you, Alexander, for inviting me.
This has been another episode of Learning Bayesian Statistics. Be sure to rate, review, and subscribe to the show on your favorite podcatcher or on Podchaser, and visit learnbayesstats.com for more resources based on today's topics, as well as access to more episodes that will help you reach true Bayesian state of mind. That's learnbayesstats.com. Our theme music is Good Bayesian by Baba Brinkman, with MC Lars and Megaran. Check out his awesome work at bababrinkman.com. I'm your host, Alex Andorra. You can follow me on Twitter at Alex_Andorra, like the country. You can support the show and unlock exclusive benefits by visiting patreon.com/learnbayesstats. Thanks so much for listening and for your support. You're truly a
good Bayesian. Change your predictions after taking information in. And if you're thinking I'll be less than amazing, let's adjust those expectations. Let me show you how to be a good Bayesian. Change calculations after taking fresh data in. Those predictions that your brain is making, let's get them on a solid foundation.